Hello everyone, this is Sudhir. Welcome back to my class. In this class, we are going to discuss completely introduction part of logarithms. So this is completely new topic to you, but so step by step we will discuss. So what is a logarithms and what are the uses of this one and what are the properties we have in this. Okay. So generally, you know very well. For example, 2 to the power of x is equal to 8. So what is the value of x here? So generally from this we write 2 power x is equal to this 8 we write as 2 to the power of 3. So in the exponents you learn well, when the bases are equal then you take powers are equal, right? That means from this we write x is equal to 3. X is equal to 3. Okay. So this is the value of x in this. And for suppose if you have like 3 to the power of y equal to something like 81, then how to write this? This 3 to the power of y is equal to, and 81 we write as 3 to the power of 4. Now you can see here again the bases are equal, then we take the powers are equal. So we write y is equal to 4. So we can find like this the value of x or y. So using this concept, and you learn already this one in exponents chapter. In the previous classes in exponents you learn this one. So how to find the value of x and y. For suppose if there is a number like 10 to the power of m is equal to something like 15 I am taking here. Okay, so 10 to the power of m equal to 15, then what is the value of m? How to find this? So this is somewhat difficult, right? Because when we have a same bases are like this, then we can take the powers are equal. But here 10 you cannot convert like 15, or 15 you cannot convert like a 10. So different bases we have there. Then how to find the value of m? So what you called here 10, this 10 is called base. This 10 is called the base, and this m is exponent, right? Now what is this 15? This 15 is logarithm of m. This 15 is logarithm of m. So how to write this one? To find the value of m from this m equal to, we get log 15 base 10. Okay, so you can follow this, and like this we can find the value of m. So this is the logarithmic concept. For suppose we take some more example. Generally we write 3 to the power of y is equal to 27. Then this 27 we write as 3 cube. So that y is equal to 3 we can write. So this is from the exponents you learn. Now the same 3 to the power of y is equal to, now when we have like 21, this 21 if you write into the prime factorization, 21 you write as 3 into 7. Okay, but not only like 3 power 2 or 3 power 3 like this. Then this y equal to, we write here y equal to find the value of y, we take log 21 base 3. Okay, so observe clearly here the value, this 3 is the base actually. So and here also we are calling this 3 as the base. Okay, so this is the base, right? So how to read this one? Log 21. Okay, so we read this one logarithm of, so logarithm of 21 to the base 3. Okay, so logarithm of 21 to the base 3. So we read like this. So don't forget, in these two cases bases are same, that is 3. Now some more examples. How to write, for example, 2 power x is equal to 10. How to write? So this is the called exponential form. This completely is called exponential form. Okay, exponential form. So how to write this one in the logarithmic form? So that is x is equal to, observe how I am reading this, x is equal to log 10 base 2. So we write like this, log x is equal to log 10 base 2, and this is called logarithmic form. Okay, so I am writing in the short form log form, that is logarithmic form. So log 10 base 2, generally how to read it, logarithm of 10 to the base 2. Okay, so what is the definition of the logarithm here? So to find in these cases, so because previously we have discussed it, this is very easy to solve this type of equation, but when we have a different basis here, so then to find the value of that variable, like that exponent, maybe x or y or something like m, to find out that, so we should use logarithmic concept. Okay, so what is the definition of the logarithms? So here I am writing, if a power x is equal to m, this is exponential form. Okay, if a power x is equal to n, then we write here x is equal to log n basis. So this is called a logarithmic form. Okay, so this is exponential form and this is called a logarithmic form. So here some conditions we have there, that is where a greater than 0. A greater than 0 means it should be a positive. That means this base, okay, this base should be a positive. That is a condition here, a greater than 0 and a is not equal to 1. So a is greater than 0 and a is not equal to 1. You should not get 1 also. So these are very important conditions. And similarly, that n is greater than 0. It should be a positive. Okay, this value also should get a positive number. In case if you get a negative number, it does, the answer is does not exist. Okay, n, what is n here? N are real numbers. It should be a real numbers. So if you want to take this one screenshot, it is very important definition for logarithm. So this is the definition of a logarithm. If a power x is equal to n, then we write x is equal to log n base a, where a greater than 0 and a is not equal to 1, and n should be a greater than 0, means positive number. And what is n here? It should be a real numbers. Okay, it should be a real number. So real numbers mean no, it should be a natural number, whole number, integers, rational and irrational. These all together are called a real numbers. So this is the definition of a logarithm. Okay, now we will discuss some important properties of logarithm. So the first property of a logarithm, that is very important, and if you know these properties well, and you can solve very easily this exercise completely, that is exercise number 5. So log mn base a is equal to log m base a. So when we have a into here, like a log m into n base a is equal to log m base a plus log n base a. Okay, or we write here like log xy base a, we write it log x base a plus log y base a. For suppose if you have a log 15 base 10, so how to write this? This log 15 we write as log 3 into 5 base 10. Then you write log 3 base 10 plus log 5 base 10. Okay, so this into we write like this, log 3 base 10, log 5 base 10. But why should we write like this? So what is the condition or what is the logic we have in this? So we will discuss, that is proof of logarithms. Okay, that is the properties of a logarithms, and we called it is a laws of logarithms also. So how to prove this? So to prove this one, we take, let log m base a equal to, generally we take here, let log m base a equal to x. Okay, so from this, and we take one more, log n base a is equal to y. Okay, so these are the two I am taking, log m base a equal, that means this one as x and this one as y I am taking. Okay, don't get any confused. So this is the logarithmic form. So from this we write it exponential form. So you know how to write it exponential form, that is m equal to, okay, observe here how I am writing m equal to, this one you get as the base here, right, a to the power of x. Similarly here n is equal to, we write a to the power of y. Okay, then so what we do now, we should multiply both. You can multiply like m into n. In this case m is, observe here, this m equal to a to the power of x into n equal to a to the power of y. Then m into n equal to, that means mn equal to, this is a power x into a power y, from exponential you know a power x plus y. So this is the laws of exponents. Log, that is a power m into a power n is equal to a power m plus n, or a power x into a power y equal to a power x plus y. So these are the formulas. Now finally you can observe here, we got one of, that is, it's an exponential form, right? So from this exponential form, how to write logarithmic form, that you know very well, x plus y equal to, so from this we write x plus y equal to, we write now log mn base a. So what is x? What is x? X is equal to, here already we have taken, that is log m base a. Okay, we write log n base a, and what is y? That is log n base a is equal to, finally we prove that log m into n base a. Okay, so these all formulas you must note down in your book and you should practice it very well. This is the first proof. Okay, first laws of algorithm, or we call it is a properties of algorithm. It's a first condition. So let us discuss some second condition. The second condition is, second property is log m by n base a equal to, we prove log m base a minus log n base a. Okay, so I will give an example. So how to write this? First, suppose if you get log 9 by 8 base a, like this is there, so, or 9 by 8 base 2 is there for suppose. So how to write this? We write log 9 base 2 minus log 8 base 2. So like this we should write. So this one we can convert like this. Okay, so but how to prove this one? The log, how can we prove? If you know the log, we will write the particular number like log 9 by 8 base 2 means we write like log 9 base 2 minus log 8 base 2. But why should we write like this? So that one we will discuss. So like in the previous one, how we discussed in the previous one with the same model. So in the proof we take as usual, that is let log m base a is equal to x. So from this I am going to write it exponent form, right? How to write exponent form? How to write exponent form? That is m is equal to a to the power of x. Take this one as a condition number 1. Okay, and second condition, this time we take let log n base a is equal to y. So how to write this? Then n is equal to a to the power of y. Condition number 2. So So we divide now both. Divide 1 by 2. So let us know what is 1. That 1 is here m and 2 is here. That 1 is again a to the power of x and 2 is a to the power of y. Okay, so in the next step we write m by n is equal to a to the power of x divided by a to the power of y is equal to a to the power of x minus y. So because you know already the formula is very well, since a power m by a power n equal to in exponents you learn this a to the power of m minus n. I used this formula so that m by n is equal to log x minus y. So we write from this x minus y equal to, because of this is exponent form, right? So how to write in the logarithmic form? X minus y is equal to log m by n base a, right? So this one, right, log m by n base a we write. So this is called logarithmic form. So this one is exponential form. So we write from exponential form to logarithmic form. Okay, so now what is x and what is y? You can observe this is x and this is y. So tell me what is x here? That x is log m base a minus what is y? Log n base a. Okay, it is equal to log m by n base a. So this is the proof here. So log m by n base a is equal to log m base a minus log n base a. So take screenshot this and practice very well and note down in your book this condition also. This properties of logarithms also very important for the point of examination view. And third property. So mostly we will discuss the three properties, and here is the third property. That is, prove that log m to the power of n base a equal to base a that equal to n log m base a. So what about this? This is, for example, you have log 2 cube or base 5 something. So these 3 you get here. That means we write 3 log 2 base 5. So from this condition to we write this one. That means these 3 we get in the front here. So that is the formula. You can use this one. Log m power n base a equal to n log m base a. So how to prove this one? With the same logic again, we take in a proof. Okay. So what we take here, log m power n base a equal to, so let m equal to a to the power of x. This is what? Exponential. So from exponential to logarithmic form, how we write it? X is equal to log m base a, correct? This is logarithmic form. Now we take here m power n. Okay, in this, just in this, what I'm going to do, m power n. So both sides I'm going to take power n. That means here also a power x whole power n. That means m power n is equal to a to the power of n into x, right? Because you know the formula very well. Here I am writing from exponential, one important formula. It is a power m whole power n equal to a to the power of m into n. So using this formula, we write log x power log a power x whole power n is equal to log nx. Now this is exponential form. From exponential form to we write logarithmic form. So how to write logarithmic form from this? That is nx is equal to this one. This nx is equal to, here we write log m power n base a. So we write here as usual n means just n only, but x mean, you see this one, what is the x here? Log m base a. Okay, log m base a. This is equal to, we write log m power n base a. Okay, hence proof. So this is the proof. Very important, this proof also. So this one also take a screenshot and practice very well. Next remaining property just orally we discuss, that is fourth property, that is what? Log a base a, that equal to 1. So how log a base a equal to 1? So for suppose, you know very well, like 2 power 1 is equal to 2, 3 power 1 is equal to 3, 4 power 1 is equal to 4. So these are the exponential form. From this, how to write a logarithmic form, that is 1 is equal to log 2 this base 2, right? Similarly, how to write from this, 1 is equal to log 3 this one here, right? Base 3. Similarly, here this 1 equal to log 4 base 4. So that means log a base a equal to, you can observe now this one, log a base a equal to 1. Okay, that means when we have these two are equal, observe here one more time, when you have these two are equal, that result is equal to 1. So how to prove this? We have a power 1 equal to a, correct? Then from this you write 1 is equal to log a base a. So therefore that's the reason we write log a base a equal to 1. So you must note down this property also, very important. Just learn well this formula, right? Next, fifth property, log 1 base a equal to 0. How log 1 base a equal to 0? So we will discuss. In the exponential form, you know very well, 2 power 0 equal to 1, 3 power 0 equal to 1. That means a power 0 equal to 1. Anything power 0 equal to 1, you will learn very well in exponential. From this power, that power 0 equal to, you get log 1 base 2. Similarly, in this case 0 equal to log 1 base 3. Similarly, in this case here this 0 equal to log 1 base a. That means log 1 at any base, is the result is 0. Okay, so how to prove this one? As usual, we have a power 0 equal to 1. So this is actual exponential form. From this logarithmic form, 0 equal to log 1 base a. Okay, so log 1 base a equal to 0. Finally we do like this, log 1 base a equal to 0. And the next property number 6. Okay, so just you can keep in our mind how to write this, log a to the power of log m base a equal to, the answer is m. That means when you are solving a problem, if you have like 2 to the power of log something 5 base 2, then the result you will get, when you have these two values are same, okay, like this, then you will get, this is the answer, means what? 5. Okay, so now one more example we will discuss. First, suppose 4 to the power of log 5 base 4. Okay, so here when you have a same value, the result is this one, that is again 5. So very important, just you note down this condition is enough. The proof is not necessary for this. Okay, so a to the power of log m base a is equal to m, we write here. or if you want a proof, I will give you a proof roughly here. So to prove this one, what you do, you take let log m base a is equal to x. And what is exponential form from this? A power x is equal to m, right? Then what is actual question here? Question is this one, that is a to the power of log m base a. Okay, so that means we have there this one, log m base a is equal to x, right? That means here x is equal to log m base a. So instead of x I have written log m base a, but here is equal to m is the answer. Okay, so very important this property. Many problems we will solve in the 1 mark questions. So these all are the most important properties we have discussed. So go through these all properties. That means total 6 properties we have discussed. Go through this, all 6 properties are very well, very important these are, and you note down these all formulas and learn very well, and then you can feel that exercise problems are very easy, right? So some important keywords here. So logarithms having base e are called natural logarithm. For example, if I write like log 5 base e, okay, or log 8 base e, these all are called natural logarithms. These all are the natural logarithms. The definition I repeat once again. Listen carefully and note down this. Logarithms having base e, logarithms having base e are called natural logarithms. So these are the example. You can see there log 5 base e, log 8 base e. These all are the natural logarithms. And we have another one, common logarithms. Common logarithms mean logarithm having base 10. I repeat once again, logarithm having base 10 are called common logarithm. For them example, log 2 base 10, log 5 base 10. So like this, if you have a base 10, then this is called common logarithms. Okay, so very important two definitions. So you must note down these two definitions also. So I repeat once again, what is natural logarithms? The logarithms having base e are called natural logarithms. The logarithms having base 10 are called common logarithms. Okay, so these are the complete introduction part of logarithms, right? So in the next class we will discuss what are the exercises problems are there based on these logarithm concepts. So very important. So don't get any confused. If you have any confused, check it one more time, this complete video. Okay, so very deeply we have discussed all the points here. So very important topic, learn very well these all the formulas. So this is Sudhir, thanks for watching, see you soon.